here's a couple tools here that we can use to do the same thing. They have better eyes than we do because they use this technology that's been developed, and it doesn't really influence. I might see something different than Kelsey does. I might be colorblind, she's not. This shouldn't be colorblind. So this is a chlorophyll meter. I don't know where my little disc went, but the first thing about it, there is a calibration disc you put in here. First you turn it on, and then squeeze it, and it will give you a number. And it will say on the back of that disc what that range should be. And it's specific per instrument. So if I have 3 of these and I lose 2 of them, chances are that calibration meter is not going to be dead on for this machine. So it's important to keep that with it. I don't know where they went, but it's somewhere. So what we do, somewhere around Feeds 5, this is used for your second nitrogen. The big plants, okay. And before I move on, this guy here in the green, Lloyd Murdoch and John Grove, they did a lot of work with this stuff early on. I mean, it's the people that came before me that did a lot of this advancement. This is one of the Wheat Science Group has the name. It's the Lloyd Murdochs, the Jim Herbecks, the John Groves. So I'm just trying not to mess up anything that they've done. But anyway, this tool, we'll pass it around. We can do it. Let me just grab a leaf. It's taking an average measurement, just like you are when you're visually assessing it out in the field. You're not looking at one plant and making that decision on the whole field. You're looking at several plants in the field. So we want to take the same measurement, the same place on about the same leaf. Flag leaf, or if this stage, but a similar, that's what I believe I pulled. But we want about the same leaf position across the plants. And y'all correct me when I get off if I do. Put it in, okay, another thing about this, we can average every time we take a number, it will give us one, or it can take individual numbers. So we want to average, so if you take 10 measurements, now it's going to give you an average that you don't have to necessarily write down. You write down one number instead of 10 and do math. Put it in here across the line, give it a squeeze. 44.5 is what that read. I'm going to do it again. This is a different leaf. 47.5. We'll do it again. Hopefully we get a close 46.9. So that average is going to be somewhere around 46. So they developed a formula here. Nitrogen rate equals 6 plus parentheses. It's on this data sheet here. And then there's a using chlorophyll meter to make nitrogen recommendations in your packet. But it says 6 plus 7 times D. And D is going to be the difference between the reference reading and the sample reading. I probably failed to mention that right at the beginning. So what we do need is a strip that we know has ample nitrogen. A lot of times we'll say that enriched strip should be 150 pounds of nitrogen. We know it's not lacking. That's going to be as dark as it should be. It's going to have as much chlorophyll. What the difference between that high rate is and what that measurement we get, that's what we're going to use to determine our nitrogen rate. So we've got this data sheet here that hopefully, like I said, we'll get to use out in the field. We have a lot of different nitrogen rates set up in the field, but you have your reference strip and then what you have, the difference, and then the N rate. It's a simple formula to apply. So any questions on that? Any comments? I'm a soil scientist and I use this example a lot. I know how old Lydia is there in the back. Turn around and look at her, everybody. So if I pick one number, then it's Lydia. to represent the average age of this room, am I going to get it? I'm not. She's probably the youngest one in here. Thank you for being here, Lydia. If I pick, I'm going to say this guy over here because I know how long he's worked here, 40-something years. He won't represent it. If those are the two numbers I get, it's going to be closer. Any three numbers I get is going to get closer. So I don't know if there's an absolute number to pick. Generally, the more the better. I would say a minimum of 10. It just depends on how big the field area you're representing. But I'd say a minimum of 10. If you've got the time to do 20, that's even going to be better. It was going to be a quiz. Is this nitrogen or sulfur? Based on everything we saw, this was sulfur deficiency. Was this Tom Miller that brought that? That's what I think. Ballard County. And it was the same type of thing. I believe this was old terraces that they formed, so they scraped the topsoil off, low organic matter, low sulfur because of the organic matter, more shallow rooting depth. The other place that I saw was in Union County, and it was a similar type deal. It was a farm that they had oil production on. The guy that, right before he bought it, the farmer cleaned it up, did some dozer work, piled brush piles, and then burned it and then buried them. So it was spots probably 2 tables wide, 4 tables, 3 tables long, just little spots like that. And then when we took soil samples there, the tissue sulfur was about the same. But if you burn wood, you can really raise your soil pH. So we had a pH in that affected area of about 7.5 to 8, which is a lot higher than we typically have. Go 10 feet out of that, it was 6.5. The the phosphorus, I believe, in that area that showed the sulfur deficiency was single digits, and then we go out and it was 45 or 50. So even though we saw those sulfur deficiencies, I didn't feel comfortable saying it was due to low sulfur or widespread. 20 years ago, we were probably depositing 20 pounds of sulfur per year through atmospheric deposition. Now we're probably 10 or less, depending on where you are in Kentucky. That doesn't sound like a whole lot, but we've deposited sulfur for, since the Industrial Revolution. And that 4-inch or 6-inch soil sample, there's a couple things going on with that. One, sulfur is somewhat mobile, so it's an anion. Most of the charge in the surface soil is negative, so you have a negative and a negative, just like a refrigerator magnet. It doesn't stick. Like nitrate, it can move through the soil profile. So now we have a 4 or 6-inch sample that's showing low in sulfur. Well, it might be down 12 inches, it might be 2 foot, but the roots can access it. The other thing is, I'm not sure, I believe Indiana uses the Malic 3 soil extractant. We use Malic 3. Waters Lab in Owensboro uses Malic 3. A&L or Waypoint in Memphis. That's the 3 big labs that our producers hit. They use a Malic 3. Malic 3 is not very good for determining the sulfur that is present in the soil. It's just not a very good extractant. So even if you have a soil test of 8 or 10 or 12, that doesn't really tell us a whole lot. I made a joke the other day. I said, it could say unicorns and popcorn and mean just about as much as the soil test sulfur value for what we have. So that's something we're really trying to do. I would say 99.9% of the fields in Kentucky, minus those anomalies like low pH, probably will not respond to a sulfur application. But what do we do for that 0.1%? Do we say everyone in the state needs to apply sulfur? No, I don't feel that's a good way to go as an extension specialist. So tissue sampling is a good tool. We have sufficiency ranges for sulfur. Tissue sampling in itself has some problems. You could take a sample right now in the rain and then go back tomorrow after it's dried up a little bit and the sun's shining, get two different readings. It's a snapshot in time right there. So you have to be aware of those tissue samples, but that's a good way to look at it. And then look at the crops that are most likely to show sulfur deficiency. So we get a fair amount of sulfur from the mineralization of soil organic matter. So when is mineralization rates going to be the lowest? Over the winter. So a crop like winter wheat is a good crop to determine, hey, what's my sulfur status? Look at that in the wheat. You're going to have low mineralization rates. Crops with high removal. Alfalfa removes about 5 pounds of sulfur per ton of biomass. So alfalfa is a good indicator crop. And I just remember when I said that, Clint called me in. He's from Davis County, the extension agent there, and it was an alfalfa field, and it was just right on the side slope. It looked like if you go out to a baseball field, red clay with sand, that's what that field looked like. And we went and put sulfur on it, and it actually greened up pretty quick. But it was just that side slope. So look for those areas. Getting back to the crops, wheat, a winter crop, alfalfa, high removal, high demand, or then just a high removal system. If you're corn silage followed by wheat silage, you're removing a lot. So those are the places that I would look first. And then, you didn't really ask this, but I'm going to go on with it for a second. Gypsum, for the most part, some people think gypsum, because it has calcium in it, is a good liming source. Gypsum is not going to change your pH. Don't buy it for that. We've heard a lot about gypsum really improves soil structure. Yeah, in some really, really, really bad soils, it can help. But most of the places in Kentucky, except for oil brine spills and things like that, you're not going to get a benefit to soil structure improvement with gypsum. Where gypsum comes into play, in my mind, the best place to use it is when you either have a confirmed sulfur deficiency or you're in a system that I don't want to risk it. It's cheap. So about every 100 pounds of gypsum, you will get 20 pounds of sulfur. Sulfur is taken up as a sulfate form. It is readily available. I mean, it's not going to be, put it down today, it greens up tomorrow, but in a week or so it will. It's not as soluble as ammonium sulfate, but it's a lot cheaper. Get it down in time, that's going to be your best route. So probably 100, no more than 200 pounds of gypsum per acre should take care of your needs for a year. And if you suspect it and don't really have it confirmed, hey, it's too big of a risk, with the technology we have today on the tractors, the spreaders, the combines, you can put strips out in your field. I mean, don't cut a field in half and say this one gets sulfur, this one doesn't. Make strips through that field, side-by-side comparisons. Then when you thrash your wheat, look at the combine, come back and look at the yield data and see what that says. So that was probably more than you asked for about sulfur, but that's a good question. We get a lot, and I'm really glad you brought it up. Any other questions about sulfur or while we're talking? Okay, so I'll pass this around here in a minute, but I'm going to talk about the green seeker. And again, that was a lot of work that Lloyd Murdoch did. If you notice, he's the first author on both of these publications. But it's sensing the amount of biomass and greenness. Probably biomass is more of an overwhelming factor than the greenness. And they have some mounted to sprayers where it's actually sensing as it's going based on what it's hitting right here. It's putting out a varying rate across the field. One thing I believe that people thought, well, we're going to reduce our overall nitrogen rates with that. And that's not necessarily true, but it puts on the proper amount based on the status of that crop. So it might put, instead of a uniform broadcast application, we might have less in spots because it doesn't need it, more in spots it needs more. So it's not necessarily going to reduce your overall rate, but it should put the proper amount of nitrogen there. Again, it comes back to an enriched strip. We want to make sure that we're comparing that to a spot that has ample nitrogen. We're not limited by nitrogen, so compare that to the number given. And they developed two formulas. Let me go back to this. The height does matter with this handheld. I don't know who's real tall, but Kelsey's real short, so we'll use her. So if Kelsey's down here holding it low, and then I'm up here holding it higher, we could probably get a different reading. The consistency is pretty important with that. So, I mean, it's a good thing I walk at my hip level or whatever, and you're catching something that's representative of the field. With this tool, you asked how much that cost. This one cost me $479. I think I got a little bit of a discount, but for about $500, you can have one of these. That enriched strip, you need it for every field. Don't just put one out. I've got 1,500 acres of wheat. I don't care much about this field. I'm going to put an enriched strip here, and then I'm going to compare everything to that. You need an enriched strip in each field to do that in-field comparison. So Dr. Murdoch developed two different formulas. One is for well-drained to moderately well-drained, and then the other formula is for somewhat poorly to moderately to somewhat poorly drained. If you look at the bottom of this, you have those two different tables. Where we are, this farm, little history lesson, this farm is pretty unique in one aspect, that this side of the road is mostly limestone soils, well drained, the Kreider type, Pembroke. We go a mile that way or less, and we run into the Fragipan soils. So we have a unique opportunity here to look at two different soil types. And I'd say a lot of the work was done here. I know you worked with Don Halcomb on this and Phil Needham, I believe. So a lot of the work was done here and then across the state to verify it. But you have the NDVI, Normalized Differential Vegetative Index reading, NDVI, for your enriched strip. And then you have your reading for the area of interest. And then you subtract that and you get your differential NDVI, which is this third column here on the worksheet. And then just plug it in to this formula with your handheld, and it will give you a nitrogen rate to apply. Now that's if you're looking with this. Now on and help me out here if I get off track, the ones that are mounted to a sprayer, that algorithm or formula is already plugged into the sprayer. So when it's sensing, okay, I know I'm on a Fragipan soil, we're using this algorithm, and it's putting out this rate. We know we're on a well-drained soil, it's sensing this, it's putting out that rate. I don't have a good feel. I think less than half of the wheat in this area actually got a first shot of nitrogen. I don't know. So, okay, you would go with less than half. We're in one of those transition areas that on some of these snotty soils, as Dr. Grove says, it's not good tracking this time of the year. So when's a good time to get my equipment over it? When the ground's frozen. That sometimes works, but you could be potentially setting yourself up for trouble from an agronomic standpoint or an environmental standpoint. We're pretty fortunate right now in Kentucky. We don't have a lot of regulators telling us what to do, but you go to Delaware, Maryland, Virginia, these sensitive watersheds, they're telling you what you can do and when you can do it. I can't remember if it's March 1st or March 15th, But in Maryland and Delaware, you cannot make any nitrogen application before that date. So we don't want to be in that situation if we don't have to. And one of the things we can do is use our nutrients wisely. So I understand why people make a frozen ground application. I'm not going to endorse it. I'll say that. And then on the agronomic standpoint, okay, I put it down, the ground's frozen. We had this perfect scenario a couple years ago that ground was frozen, I could run, but then all of a sudden it warmed up enough, we got 2 or 3 inches of rain, and that just set us up for that nitrogen to move. And I wish I had a drone at that point, but a lot of our fields are not flat. We don't have Indiana, Illinois fields in a lot of places. So, I think this moved, and we have a lot of basins. A lot of it moved from these flat spots or these upper landscape positions to the basins. And then you had these basins that got a lot of nitrogen and actually showed a lot of lodging. So if it's going on a basin, at least it's not leaving your field directly, but sometimes it could be washing straight into a watershed. So that's one way we can lose nitrogen. Ground's frozen, water can't go in, it takes it off. But take that scenario out. This time of year, our biggest nitrogen loss is probably denitrification. The microorganisms in the soil actually utilizing oxygen as a terminal electron acceptor, so they start grabbing oxygen or electrons from that oxygen and nitrate. Once it's out of the nitrate form, it is not available to the plants. So there's some information in this packet that talks about this. This was something, again, Lloyd Murdoch worked up. It's table 1 on the second page. But what you need to know is what percentage of that nitrogen is in the nitrate form. So we think most of the time we're not losing. If we're not losing it in runoff, the next place we're probably losing it is denitrification. So if it's all in the ammonium form, we're not going to lose any to denitrification. It only happens to NO3 minus. If it's NO4 plus, that's okay. Rice paddies, they fertilize with an ammonium source because it's not going to denitrify. As long as it's saturated, it's in ammonium form, rice can actually take it up when it's saturated. But in most situations, we're going to have this nitrification of ammonium to nitrate. When it hits that nitrate form and then we get waterlogged, we can lose some. So there's about 2 days worth of oxygen in a saturated field to keep the microbes happy. When you hit day 3, you're going to start denitrification. The research has shown we can lose 3 to 4% of nitrate per day. So there's 2 examples in here. One, we used urea. Urea starts out as the ammonium form. So if it put down it now and we get a nice rain like we're having right now and it rains for a week, we're not going to lose any as long as it's not running off. But if we put it down 3 weeks ago, it was warm enough for nitrification to occur. With urea, looking at this table, 3 weeks after application, half of it is in the nitrate form. So if that initial shot of nitrogen we put down, half of it is now subjected to losses. So if we have, let's see this example here, 50 pounds of nitrogen is urea. It was saturated for 12 days. Half of it is going to be in the nitrate form. 12 days, the first 2 days don't count. We have 10 days that's saturated, so we can lose 30 to 40% of that nitrogen that we put down. We put down 50 pounds up front, 25 pounds of it is nitrate, so it works out that we could have potentially lost 7 to 10 pounds. That's 30 to 40% of that nitrate. Sounds like a big number, but I'd say the majority of the people that got their nitrogen down and it didn't run off in the move in the runoff, you haven't probably lost as much as you think you have, which is a good thing. The UAN, or we actually have a dealer here we can get ammonium nitrate for. Ammonium nitrate, day 0 you start out at 50% nitrate. UAN, day 0 you have 25% nitrate. So look at your fertilizer sources. Use this table. It's been proven to be pretty accurate over the years. It's a good resource to have.